Hey guys, Tom Shu here, and today we're going to be talking about some lithium polymer batteries, also known as Lipo batteries. Lipos, they're really powerful batteries that can be charged quickly. They can dish out lots of voltage and current. However, they're kind of dangerous if you don't know what you're doing when you're working with them. So if you've never played with them before, do your homework and figure out what's going on with them before you go out and just drain one down to it's dead and watch it catch on fire. You see, these Lipo batteries, lithium polymer batteries, they can only be discharged to a certain point before they get damaged or malfunction and catch on fire. And there's a rule of thumb: if you don't drain your battery below 80% of its capacity, then you can extend the life of your battery too. Considering I just spent like $300 on a couple 8,000 milliamp batteries. These are 6S batteries that happen to be 30C. I want to make sure that they last as long as possible and they perform like they're supposed to. So let's just go over a couple things on the 6S battery. You see, these batteries, they're divided into cells. Depending on how many cells that you stack together, you will get a voltage. For example, 6S stands for 6 cells, and fully charged at 4.2 volts per cell will give you a 25.2 volt pack. Okay? Now, at 80%, if we do the math, you'll see that at 25.2 full, 80% of that is 20.16, and if we divide that by 6, which is the number of cells in the pack, it gives you a 3.36. Now this is the bottom where I want to be under load. You see, these batteries will rebound. Say for example, I have full throttle going and I hit this 3.36 volts per cell. Basically I drop it down to 20.16 volts and I let off the throttle. The battery will rebound and it will show a higher voltage. Okay, so we want to set this under load, not at rest, as our threshold is 80% maximum. So if we set a little bit of padding instead of dropping it down to 3.36 per cell and did something like 3.6 volts per cell, we know that we're always going to be within our 80% threshold, and this will be our first level of protection. So how to actually do that? Well, your motors are controlled by what's called a speed controller, and I happen to be using Castle because I think they're fantastic. Secondly, they have this real cool piece of software that lets you program them. Okay, it's called Castle Link, and when you buy one, they'll give you a free card to get a Castle Link USB controller. Okay, so you get it for free, and when you hook it up, you'll get this screen. This is called your splash screen, and when you're done, you update your settings here, or you can set everything to the default. Okay, so we'll just do that. We'll set everything to the default. Click OK. So now this thing is set up just like it would be if you bought it brand new. So you go under the throttle type and it's going to ask you what kind of vehicle it is. This will let you do all kinds of things as far as governors and set up different modes. But in our case, we're working with a multi-rotor. So we're going to choose multi-rotor, and it gives you this warning about improper usage of this mode. It can cause your speed controller and motor to fail. Basically, since you have such fast throttle response, it'll draw tons of current, and if your speed controller and your motor can't handle it, you'll burn it up. So we'll just get rid of that, and this gives you throttle type of fixed endpoints instead of being able to do a curve for throttle response. Now braking, this is also disabled, but cutoffs isn't. Okay, now if we go back and look at our document here, we know that our first line of protection is going to be 3.6 volts per cell. So if I look over here and I choose this automatic lithium polymer as the voltage, I could choose it auto lipo, and I say, hey, I want it to stop at 3.6 volts. This will ensure that my batteries are protected. Now as far as this cutoff is concerned, there's a few ways you could do a hard cutoff, which means it just stops them dead in the tracks. So we go to soft cutoff, and if you're ever in question of what something means, you click on that little blue square and it tells you. So if we look down here under soft cutoff, when the pack reaches the cutoff voltage, Power of the motor is reduced until the pack voltage rises above the cutoff. Power is then continually modulated to maintain the cutoff voltage. The motor will appeal to hunt and set for speed and slowly have less and less power if held at full throttle. So basically, this will let us know when it starts messing up that it will we've hit our voltage and we can bring our craft down. So I'm going to put this on soft cutoff. Okay, and you can also set it under current limiting, which we don't really need to worry about that. We're using 75 amp. Let's leave it there. Okay. Some other things that you can do with this is you can choose the direction. A lot of times people will just have to flip the wires on their ESC if their motor's not running in the right direction. Since I'm doing a hex, I'm going to have 3 motors running one way and 3 motors running the other way. So I can choose forward to reverse here. I can turn if they're going to beep or not beep. I can also change the battery elimination circuit voltage. Some things need a higher voltage than others, so I can put in a custom voltage if I want and choose up to, I think it's 12 volts, I think. Anyways, we're just going to leave it at 5.5. That's plenty for our flight controller. Logging, we can choose what we want this to log. We could look at what our battery performance is, the controller temperatures, the throttle. We can control all of these things, and we can choose how we want it to be sampled. Okay, and then this is where we update the firmware. We're running the latest firmware, which is 4.14, and then we can save our settings. So say for example we wanted to use testing and we wanted to try these settings, we could save them as our default. So we just try this as first test. First test multi 6, okay, because we're doing a hex. So I click save and that's it. Now I can preview this settings. Okay, so we're going to call this test just to look at it. And this will create a document that we could print out and look at to verify everything's right. Because when you're going between menus, you don't really know what it is you've done. You might have some conflicting settings or something like this. So let's open this up and take a peek at this report. It's telling us we're doing a multi-rotor with fixed endpoints. It shows us our braking, which isn't any because it's off by default. Our cutoff is 3.6 volts and it's a soft cutoff. Our motor startup is by default medium. We can choose kind of how it starts up on the power. We're going to be running this in the forward. We've got the beeps enabled, logging's enabled, and we have the latest firmware. So we could just print save or print it out and take a peek and put this in a file so we can do our testing. So we've got all of our settings done the way we like. We just hit update. It sends all that stuff over to the speed controller and you click OK. Now since we're doing 6 speed controllers, I can take and load this file into each one of them and load it up. So it's real quick. I don't have to go in and adjust each one. So that's it. I want to thank you all for taking time to visit today. Until next time, we'll see you soon.